Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on analysis of frequency distribution. In our last lesson, we learned how to calculate two measures of variation: mean deviation and interquartile range. We also reviewed how to find the standard deviation of a dataset. Today, we will learn how to compare two groups of similar data by analyzing their frequency distribution. We will also learn about the coefficient of variation. Are you ready to begin the lesson, students? Let us get started. Students, let us begin this lesson with a quick activity. Can you think of reasons why it is important to be able to compare data? List as many reasons as you can and share your list with a classmate.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. I am sure that you thought of many good reasons why it is important to be able to compare data. When we can compare data, we can see whether it is more consistent or less consistent than similar data. We can judge how well one thing performs in relation to another thing. In general, we can put the information into proper context. This allows us to form conclusions and enables us to make good decisions. Let us look at an example of comparison together. Please copy down this table, students. Here we have the daily income recorded over 3 days of 3 small shops. If we calculate the mean for shop A, B, and C, we find that each shop has an average income of 33. We add this information to our table. Since each shop has the same average income, we will have to go further to find out which shop has the most consistent income. We will have to find the standard deviation. Let us look at shop A as an example. Please copy down this table. Using 33 as the value for the mean, we can find the deviation of x from the mean and the square of the deviation. The sum of the squared deviations is 122. Students, please complete similar tables for shop B and shop C. Then, using these values, find the standard deviation for each shop's income. To refresh your memory, the equation for standard deviation is the square root of the sum of the squared deviations divided by the number of observations less 1. You may begin the exercise now, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Please compare your answers to these. We have already completed the table for shop A together. Using these values, we find that the standard deviation for shop A is 7.81. Your table for shop B should appear like this. Using these values, we find that the standard deviation for shop B is 9.16. Your table for shop C should appear like this. The standard deviation for shop C is 5.29. If these were your answers, great job! What do these results tell us, students? The standard deviation for shop C is the lowest. Thus, shop C has the most consistent income. It was relatively easy to compare those sets of data because they had the same mean and the same unit of measure. However, you may run into situations where you do not have the same mean or the same unit. It is difficult to compare two data sets when one measurement is in kilograms and the other is in centimeters. In fact, it is only possible if you use the coefficient of variation. The coefficient of variation is a pure number that we use to measure the degree of consistency given as a ratio of the standard deviation to the mean. The equation for finding the coefficient of variation is as follows. The standard deviation divided by the mean multiplied by 100. Students, please find the coefficients of variation for shops A, B, and C. Recall, they each had the same mean of 33, but the standard deviation for A was 7.81, for B was 9.16, and for C was 5.29. Please go ahead with the activity, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Let us see if you found the correct answers. For shop A, the coefficient of variation is 23.67. For shop B, the coefficient of variation is 27.76. For shop C, the coefficient of variation is 16.03. Were these your answers? Well done, students. Since the coefficient of variation was the lowest for shop C, we have again proven that shop C's income is the most consistent. Students, let us look at one more example together. A survey was conducted to evaluate the performance of workers in 2 factories. Employees in Factory A worked an average of 30 hours per week. The standard deviation of their performance was 5. Employees in Factory B worked an average of 28 hours per week. The standard deviation of their performance was 8. By finding their coefficients of variation, we can determine which workers were more consistent in their performance. For Factory A, the coefficient of variation is 16.67. For Factory B, the coefficient of variation is 28.57. We can see that the workers of Factory A were much more consistent in their performance than the workers in Factory B. Students, you probably recall from previous studies that statistics is a 5-step process. These steps are collecting, organizing, presenting, analyzing, and interpreting data in order to draw conclusions. Today, we covered some very important material related to analyzing and interpreting data. You learned how to compare 2 groups of similar data and how to determine the consistency of data using standard deviation. You also learned how to compare groups of data that are measured in different units. Until next time, thank you, teacher. Thank you, students.